Thank you, Shafin. Welcome, everyone. Today, we will be using this assembly model to demonstrate Creo Simulate workflow. So the first task is to launch Creo Simulate application. To do that, we need to go to this Applications tab. And as my colleague Shafin mentioned earlier, if you see something like this, like it's not grayed out, it means you have installed Creo Simulate correctly, and you have the appropriate license to run Creo Simulate. Let's start by clicking it. Okay, as soon as I start Creo Simulate, you can see a few more entities on your graphical window, and also on the model tree, we have some extra entities. These are only specific to Creo Simulate. However, I have predefined this model. That's why we can see these entities. If you start Creo Simulate for the first time for your own model, you will not be seeing these entities. Once you add them, you can see them. All right, the first step, as Shafin mentioned in his workflow, is to assign materials. To do that, we go to the materials, and we have the option to create a material by clicking that. You can give it a meaningful name, and you can fill up all the parameters of the material that are relevant to your analysis. However, you also have the option to select a material from the huge library that already exists in Creo Simulate. For example, let's go to standard materials grant a design, and from non-ferrous metals, let's select titanium. So all we need to do is just double click this material, and sorry, it is already there. Let's select something else. Let's select zinc. So it is now added to our model. We just simply click OK. So it is added to our model. Now we want to assign this material to our components. To do that, we click on the material assignment, and we have the option to select one component, or we also could select the top level assembly to assign this single material to the whole assembly at once. If you notice my model tree, you will see I have already assigned a material. So I'm not going to click OK. OK, so once you select the component from the material drop-down list, you can see the newly added material. OK, I'm just going to cancel out of here because I have already assigned the material for my assembly. All right. Next is we need to set some constraints. So what are constraints? As the word suggests, these constraints are used to lock your model in 3D space so that it doesn't move when you apply a force. Okay. To assign a constraint, let's say this base surface, we want to completely stop it from moving. To do that, we can select this surface, and from the ribbon, we can select displacement to stop its displacement. Or we can select it, and from the mini toolbar, we can select the displacement. It's the same thing. We just can do it faster from this mini toolbar. All right, Creo is by default is gonna set it to it's gonna stop its movement from all degrees of freedom. However, if you want to free any specific degrees of freedom, you have the option to do it from here. And again, from the model tree, as you can see, I have already constrained my model, so I'm not gonna click OK. I'll just cancel out of here. After you set the constraint, the next step would be applying some loads. To apply some loads, we have the loads group here on the ribbon. I'll give you an example. Let's say on this surface, we want to apply a force that's acting downward. To do that, we can simply click this force moment from this mini toolbar, and we can give it a meaningful name. Then this surface is selected. Okay, so we use this world coordinate system, which is this one at the right bottom, to define our direction for the force. For example, if we align it like this, you can see the x-axis is actually the vertical axis, which means if we want to apply a downward force, we need to give it a value of minus, let's say 150, and the unit, you can select it from the drop-down menu. Let's give it a Newton. To preview in which direction my force is acting, we can click on this preview icon, and you can see it's acting downward. However, if your model is not correctly aligned with this coordinate system, you can create a coordinate system by yourself and click here, selected, and then select your own coordinate system. All right, again, we have already predefined this model with existing loads, so I'm not going to click OK. I'll just cancel out of here. All right, so far what we have done is we have assigned a material, we have added some constraints, and we have applied some loads. The next task is to define the analysis that we want to run. To do that, we click on this analysis and studies icon, and from here we go to file and we click on new static. As my colleague Shafin mentioned earlier, these studies are only available in higher tier licenses, not available in Creo Elite. Only we can define new static as of now. So let's select new static. We can give it a name. For example, let's say analysis 2, and we used zinc as material, just a random example. And we have options to change these defaults. However, for today, I'm just gonna keep it as defaults. We click OK, and it is defined. Now to run it, all we need to do is just click this green flag and it will start running. Yeah, it is running now, and we have this diagnostic window. You can use this window to troubleshoot if you have any errors in your model. Okay, also while it's running, I would also want you to I want to emphasize on meshing. If you remember, I haven't done anything about meshing at all. Creo is smart enough to do the meshing by itself, very nicely refined mesh, and it will do everything in the background. We don't have to do anything. As you can see, our analysis is complete. However, if you do want to make some changes to the meshing, you have the option to control it yourself. All right, our analysis is complete, and you can see it took around 31 seconds to complete it. All right, next task is to view the results. To do that, we click this icon, and we have the result window definition box. From here, we can give it a title that is meaningful to us. Then from the display types, we have like fringe, vectors, and so on. From the quantity, let's start with the displacement. Let's see the displacement. And the unit is millimeter. You can change it to whichever is preferable to you. Then from the component, we have the magnitude selected. Also, you can select a specific direction where you want to see the deflection. So let's just keep it magnitude and click OK and show. All right, here is our result. If you want to edit this view, all you need to do is just double click on the window and we can edit it again. So this box will pop up again. Let's go to display options. Let's select continuous tone, and we want to deform it by a scale of 2. Then let's say we want to show the element edges, which is going to show you the mesh that used in the background. Then also you can animate the result. Let's give it a frame of 24. And all I need to do is just click OK and show. Now we have the exact same result in a different way, like it's visualized in a different way. As Shafin mentioned earlier, Creo has its own default template to view the results. We just need to cancel out of here. And again, from this window, we click this one where Creo will use its default template to give us the result. For example, here, Creo shows us the von Mises stress on one window, then displacement, and then all principal stress on the other window. We can double click any of them and change accordingly, however we want. Now at this point, we use simulation to optimize our model. If you do optimize your model, all you need to do is go back to your model, make some adjustments, and run the analysis again using the same workflow. And if you have two analyses to compare, all you need to do in Creo to compare them side by side is open from template. And these are the results that I have conducted earlier. So we can just select one of them. Let's say I want to use test, for example. We click OK and show. And it is showing us two results side by side from two different studies. That's it. I will just summarize what we did. We have started Creo Simulate app, and we have seen how to add a material. We have seen how to apply loads and constraints, and then how to define a result and how to view the result at the end. That was all from my side. I will now hand over to Paul to continue with the webinar.